Hello everyone, let's talk about another easy problem on Leetcode today. Find center of the star graph, Leetcode 1791. In this, we are given an undirected star graph consisting of n nodes labeled from 1 to n. A star graph is a graph where there is one center node and exactly n minus 1 edges that connect the center with every other node. And then we are given 2D integer array edges where edge I is the edge between vertices ui and vi, and we have to return the center of the given graph. So then in first example, we can see that the edges are 1, 2, 2, 3, and 4, 2. And because they are undirected, so it goes both ways. And we can see that the center of the graph is 2, and we have to return 2 in this case. So now let's try to understand how we can actually solve this problem. So first point to note in the star graph is that suppose we have n edges, like in this case 3, then we will have n plus 1 nodes, that is 4 nodes in this case. And the center point of the graph will be connected to all of the n edges. Rest of the nodes will only have one edge connected to them. So for example, we can see that 4 is just connected to one edge, that is one edge to 2. Similarly for 3 and 1, only 2 has 3 edges connected to it. So one of the easiest way can be that we can actually count the number of edges per node, and if the node has n edges connected to it, that means this is a center node. Now let's jump into the code part. So we will just need to get the number of edges first, and then we will just create the frequency map, that is number of edges per nodes. Then we will just loop over the edges array to create this frequency map. So our vertex u will be at the edge I0 and our vertex v will be at edge I1. So now we will just put it into the frequency map. So we will just use get or default function on map to get the frequency 0 if it's not present. Similarly, we will do the same thing for vertex v. Now that we have created the hash map, we can just see if we can find any key, that is any node with value that is number of edges equal to n. So we will now loop on the hash map, and if pair.getValue is equal to n, that means we found our answer. We will just return pair.getKey. Otherwise, we will just return -1. That's it. Now let's test this code out. Awesome. Let's run this code. Cool. In terms of time complexity, it will be O of n, where n is the number of edges or nodes in the star graph. Because both of them are comparable, so we can use either. And the reason is that we are first looping over the n edges to create the frequency map, and then we are again looping over the n plus 1 vertices in the frequency map or in the hash map. So that's why the time complexity is O of n. And in terms of space complexity, it is also O of n because we are storing n plus 1 vertices in the frequency map. So this is one solution, but wait a minute.
Wait a minute.
Do we really need to go through all the edges in the graph? Let's look at it closely. So suppose this is edge 0, this is edge 1, and this is edge 2. So what is the common node between edge 0 and 1? That is 2. What is the common node between edge 1 and 2? That is again 2. What is the common node between edge 0 and 2? That is again 2. So that means we pick up any two edges in the graph, the common node will be our answer. That will be the center node. So that actually reduces our time complexity to just O of 1 because we don't have to go through all the edges. We don't have to create any frequency map. Now let's change our code to reflect that. Now to find the common node, what we can do is we can define two nodes, u and v, on edge 0. So either of them can be our center node, right? Similarly, we will define nodes w and x on edge 1. So either of these can be our answer. So what we will check is if u is equal to w or u is equal to x. So that means u is common between edge 1 and edge 2. So in that case, we will return u, right? Otherwise, we will return v because either of these can be our answer. Let's run this code. Awesome. Let's submit it. And yeah, so now it's O of 1, so it actually beats 100%. But what we can also do is we can also convert it into the one line. So whatever I have written here, I can just replace u with h00, v with h01, right? And similarly w with edges 10, and similarly x with edges 11. So now it becomes a one-liner. Let's submit this code again. There is one U remaining. So let me replace it with S00. Cool. Let's submit it. Awesome. And in terms of time complexity, it is O of 1, and space complexity is also O of 1 because we are not storing anything. And I hope this solution was clear to you. If it was, please like and subscribe. Have a nice time. Thank you.